After having carried out the problem with two different types, you have learned how to use the user interface. Yeah, so it's a good beginning. It might seem a bit far-fetched now, but I would still like to get you introduced to an input file as to how it's set up, what is Abacus actually doing in the background, because you're also working on your own code in the meantime, because you might have read the assignment already and you know that you have to code it and you have to write it in a good format so you can get all the different results. So it yeah, it's a good idea for us to have a look or a peek into the input file. So here I just want to go into the folder, and you would do the same to get to your job. So I have the Abacus jobs here, and this is what I ran today with you. So if you see, I have all the files for one element. Once I set up the one element file, so I had a GUI file, so a CAE file, which is just a user interface. So it's all the raw information that's stored in it. Once I create a job and run the analysis, then it creates an input file, which is an INP file. Then it starts setting up all the different applications. You have an MS-DOS file, you have a status file, a SIM file, a message file, and all the results are stored into this ODB file, which is just the database, the output database. So these things are all set up for every model that you run. So you see there's one for job 1 element and there's another one for job 4 element. And I have multiple of these. I've been running all these different analysis over the last month. So if we go to the ones that we are really interested in with one element, let's just have a peek into the input file. You can use any kind of word processor to open it. I tried to use WordPad because it makes it in a good format, but you can see anything else is okay. Now, if you look carefully at this, you will see it starts with the heading. Everything with double star is just a comment. So you have a heading and then it says some information, don't do this, don't do that, and here it starts making the part. So you see all the information, you put it through clicking buttons, it also writes it down. So you have name bar. Then you created a sketch, and depending on where it was in space, it created a certain location. So this is X and Y coordinates because it was XY planar model. So you have two nodes, one node, two nodes, and these are the coordinates of the two nodes. Then it created an element. It says, okay, we are going to make an element. The type of the element was T2D2, which was 2D truss. And the element number was 1, and it has two nodes joining from 1 to 2. Then it started creating some internal sets because it wants to also set up how the results are going to be shown. But we don't have to worry about that. Then we set up the section, and we created a solid section. We picked a certain set over there, so we just clicked on that or the bar, if you remember, and we put in a certain material and we put in a certain area. And if we go further, then it went into the assembly, it created an instance, and after all this geometric data is over, it starts talking about the material. So we just made materials, and remember we wrote simple properties, so it adds it as a comment here. Then the material has a name, it's elastic, it has certain properties. Then it puts in the boundary conditions. It was just Encaster. Under step axial load, we had a load, which was P, concentrated force, of 1000 value, and it was applied at node 1. So these are certain syntaxes that Abacus follows. Then we had an output request. We changed our output request. We asked for output field of only the reaction forces and the displacement, and we asked for mysis and a strain, and that was it. And it said end step. That's the input file. That's as simple as that. So you just define the nodes, define the element, how it's set up, what kind of element it is, what are the properties, what are the materials, what are the boundary conditions. It's the same as you would do in your own code. Now this was for one element. If I also look at the one for 4 elements, the only difference I would see is the number of nodes. So I have now 5 nodes and 4 elements, and each of these elements is combined of 2 nodes. So you have 1, 2, then 2, 3, then 3, 4, and 4, 5. Just how you wrote it down also in your handwritten calculations. And everything basically remains the same. So this is a standard input file for any Abacus model. Of course, you can't open the ODB file. That always has to be open in the output database. It's just a bunch of nonsense if you see it in a WordPad file. So I wouldn't recommend you to do that. But you can go through the status file, the message file, the data file, and you can get some more information.